Okay, first of all, thank you very much for having me here today. And I would like to reflect a little bit on a few things which has to do with the technology and the barriers for making much of this come through. And I actually think that this previous presentation was a fantastic example because this was really the essence to what I have chosen to talk about today. What did we see? First of all, great presentation, great content. I really enjoyed it. But if you stop thinking twice about what we just saw, we saw some great content, great production, great technology, but when do we hit the wall? When we want to distribute it, right? Did you pay notice to that this former presentation, there were videos. It was actually not a number of still pictures that were being shown in a sequence. It was actually a video. But because of the lack of transmission technology, we were not able to see this as a video. So then you can say, what is the problem now? We have fantastic technology. We have these humongous cameras that can record in what resolution, whatever we need. And how do we as consumers over the world actually get access to this, especially if in real time? If we cannot even show an old school two-dimensional video on a screen like this transmitted from somewhere else in the world, right? So is it just an illusion or what is really going on here? That's one thing that I would like to reflect with you about. Then I have a personal reflection, which I would also like to share with you. We have today seen, I don't know how many pictures of human faces with black boxes on the front of them. How do you think that our sons and sons and daughters, whatever, in 50 years will be looking at those pictures? I think they would be laughing their butts out, to be honest, right? Maybe we get some inspiration. There are people that are working with some visions on this stuff. Anybody have seen Black Mirror? It's on Facebook. Ah, okay, guys, that's great. Most of you here, very fantastic. Okay, so I don't need really to talk about a lot of the stuff there. But then let's put it a bit ahead then, because the only thing that we really know about the time that we live in today is that things are never going to move as slow as they are today. And if we look 10 years back and we try to see what happened and what we thought about what would happen today, I remember it's perhaps a bit more than 10 years or two. Yeah, let's say 13 years, 15 years, 13 years, yes. That would be when the first mobile phones came to Brazil with color screens. I remember the articles that came out at this time. It says that, well, this will never be for the Brazilian population. Color screen phones, it's going to be too expensive, right? Look where we are today, right? Everybody has not only color screen phones, but phones, many people at least, that can actually do high definition directly. Think about something else also. If you 10 years ago were invited to a company that would like to know what life is going to be by 2015 or something like that, give me some facts on reality that are hard to believe. If you 10 years ago would tell them that a company that barely existed at that time, which is Facebook, or was Facebook, barely existed at that time, would acquire another company that did definitely not exist at that time, which was WhatsApp, for 3 times the value that Nokia would be acquired by Microsoft the same year. I can tell you, everybody in that room, depending on how visionary they would be, would say, we don't believe it. It's simply too far away. But it actually happens, right? So what happens if we think a little bit ahead, and then let's say in 15 years from now, I would like to hear you guys, how many of you think that these black boxes that we've been seeing so many of today would be substituted by contact lenses that we would have in our eyes? How many believe that in 15 years that will be a reality? Hands up. Haha, great. So, good part of the population here today. Okay, I've come to the right environment. Okay, just a few words about myself. My name is Jesper Rhode, and I started my first company back in 1992. This is me version 1.0, right? With hair and everything on the head, right? It was a software company. I started working on systems that did telecom quality measurements in networks, and I got hired by some large telecom companies to actually start working on test software that were testing on telco systems at the time there. So that was quite fun. I like fun, actually. I like doing this. Flying, actually. I'm a pilot also. I don't have one of these old-timer planes. This is a Tiger mod, I think, from 1935, but I like flying them, so every time I get near to them, I do that. I spent 20 years of my life, or more, 25 years of my life, trying to solve this problem here, right? How do we connect the world without doing it like this? Especially mobile telephony. I worked with Ericsson. Great vision of connecting roughly 50 billion devices over the next 5 to 8 years, which I think is something that is really, I mean, if you can look at the problems we have just looking at a video here from Norway, then think about connecting 50 billion devices. Some,times we do really not consider the infrastructure that is needed behind this enough, I think. Actually, I spent a good part of my time with startups in different contexts. This is actually with the team from Startup Farm, as you can see here, one of the teams that I did mentoring for. I think really I spent some great time. Last year, I spent some time on Singularity University in the US, talking about exponential technologies, exponential companies. I could talk a lot more about that. I do that in other sessions. I will keep that out here today, but I really enjoy it. And I also started as co-investor in makerspaces here in São Paulo, Distrito, that maybe some of you want to know. Sorry, that some of you know already. Okay, so first of all, we see a lot of technology, as I mentioned to you already. This is just another example on technology that we see being presented.
360-degree VR experiences.
The construction is just so professional that we put it on dollies, we put it on Steadicams, we put it on camera cars, and everybody that's gotten their hands on it to rig it is really excited about how.
So what is the message about this really?
It composed
you have these huge reaches that can do recording with fantastic quality. We saw some of them on the videos right before also. And the thing about them is that these videos are actually really content bombs, not just in the terms of the content that they actually have, but also in terms of the size of this. These are videos from Jaunt in the US that some of you might know that also produces VR content. Their rigs record some of the content that you are seeing here in not only, well, high definition and 360 degrees, but when we talk about 4K, or we talk about 8K. These guys record in 32K. And you can imagine that even if compressed, this video signal today, if you want to ship this out without significantly losing a good part of the content that you have there, you have to talk about something like 1 gigabit per second, 1 to 2 gigabits per second, right? So the question is then, if we cannot even see a old school two-dimensional video on the screen here, how the hell are we ever in the future going to look at stuff like this, right? And so these are some of the considerations that I would like to share together with this today. So it's not for nothing that I've spent so many years of my life with Ericsson, and actually we did a demonstration in Barcelona this year showing 5G technology, and you can see the transmission speeds here. We are actually talking about something above 20 gigabits per second. And then you can say, okay, but now we're really getting too far, because here in São Paulo, how much can we actually get on our phones here? So the question about this is actually that, yes, we will be able to, in the coming years, to get speed that are much higher than we see today. Of course, we're not going to see this distributed anywhere in the country, especially not in the countrysides. There's a well-known saying that the future is already here, but it's just unevenly distributed. What you see here is the technology, actually. The green spot here is where the base station can actually follow. This is the mobile unit that you see, also emulation of the mobile unit that you see up there. The base station can actually see where you are, and it can track you around when you move around, like you can see in this picture here. So it means that already today, technology on 5G can map up to 64 people or 64 mobile units per antenna as they are moving around in the landscape. It means that one of the problems you will have to solve when you talk about high-speed transmission is if you talk about, go back to the original laws of physics and the laws of Shannon, you learn that you have a specific amount of energy that you have to tie to each bit that you send out through the air. So if you can focus this bit, instead of sending all the signals out in any direction, but you only have one receiver over here in the corner, you can focus that energy as you do with a light bulb and your front light on your car, for instance. If you can have a kind of a reflector where you can focus all of that energy that you are transmitting to each individual mobile phone out there, you can concentrate the energy, and by that you can also get a much higher data speed as a throughput by that technology. So that is one, just to give you one example of what is being worked on in order to achieve the speeds here. But we should also remember that even if we look back in history, the data speeds that we have today are actually astronomically high when we talk about what was initially planned for mobile phones. One of my ex-colleagues, Håkan Eriksson, the CTO at Ericsson, when the GSM standard, or the 2G standards that were launched in Brazil around year 2000, 2002, when they were planned in the late 80s, Ericsson actually planned for having a data transmission per mobile phone of 14.4 kilobits per second. And by the people that were planning this, the guys from Ericsson were told that they were out of their range. They were too far out of the box, letting so much or preparing for so much data transmission to a mobile phone. Today, this morning, I checked where I live, and I could, on my 4G phone today, with the subscription I have here in Sao Paulo, which is a plain old subscription that most of the people has, I could reach 34 megabits per second. Right? So actually, this has been multiplied more than 5,000 times, actually, in terms of what we thought was already outrageous at that time. So don't expect the future to be less interesting and less engaging than we already have seen it today. Another thing about the networks that are going to work on this also, and I will just take this slide and talk a little bit about the tech stuff, is that you will see network slices that will work with the type of connectivity that you need. So if you have an emergency service, if you do remote surgery and you want to use virtual reality for that, that is the type of connection that the network of the future will actually be able to offer you. Today, when you acquire a subscription, you basically get a basic condition for everybody, right? So speed is what the network can deliver, unless that you are on 3G and not 4G and stuff like that. You know, you really get the same condition as everybody else. But what you need to, in terms of having a network that actually knows what type of service that you have, if you have a virtual reality service where you need a higher speed, you would get that higher speed, right? So depending on the service that you have, you will be able to connect to the cloud service, whatever you have, where you store where you analyze your data, whatever you do on the other side here, you'll be able to connect those through the same network, but the network be aware of all the services that you have on the other side here. And I just gave an example on the speed, but what we will see is that all of these different hookups, all of these different requirements that we have will actually mean that we will expand the performance of the network in different ways. So you will have data volumes. You will have, of course, the data rates, end-user data rates, as I gave you as an example here, with more than 20 gigabits per second. We will have technologies for low power usage. If you need sensors in the wall, on the forest, on the water, or whatever you want to put them, and you just want to charge them with small stamp-sized solar panels, that would be enough if you can do that. You'll have low latency, and I will come a bit back to why low latency and virtual reality has a lot to do with each other. So mark my words, because that is one of the biggest contributions. Beside the speed in itself, low latency is going to be one of the very big contributions that the network of the future and the technology of the future is going to give to virtual reality. But virtual reality is one thing, but then it's also a question of, do we really want to have the masks on our heads, or do we want to combine this reality with what is at the other side of the masks, right? I mean, you saw this picture before. Did you see that? The girl with the goggles on there. The only thing they could make that picture just a little bit interesting was actually pouring tons of flashy lipstick on her, right? So otherwise the picture would be too boring to see. So the problem is then now, how do we engage with the world, even if it's a virtual world, without having these untransparent goggles on front? Here's one bit on it. So here we're talking about equipment that's being used for different types of professional use, where you can actually, not just for entertainment, but actually for controlling everything from engines to industry environments, actually use these type of equipment that does all type of recording of visual light and non-visual light also, like infrared and ultraviolet. And you combine this with different types of data acquisition and analysis, so that you become aware of all the information that you need to have in order to be able to maneuver all of this stuff here. One of the areas where these type of helmets are beginning to be popular is actually in the area of building constructions. How many of you have heard about BIM? There's one there. Okay, building information modeling is an area where architects today can begin to, together with engineers and many other contributors to designing buildings, can put all their information within a virtual platform, and you can actually, once the raw concrete of a building has been built, you can put up a mask like this, and then you will be able to visualize all the installation and all the relevant information for the construction of this building when you are actually only walking inside this raw concrete building. You can walk around with your colleagues and you can begin to discuss the advantages of maybe changing some of the plans that you have for the infrastructure even before the material is already being acquired. Right? So this is just to say that virtual reality is not just immersive entertainment, but I think that the cross point between augmented reality or virtual reality and then different type of industries, in this case, building industry, is going to be a very big business. The thing about this, however, is that we need to interact with this in different ways, right? This is one of the problems with virtual reality, is how do we interact with it? Let's say, normally we can use our eyes. Lately, we begin to use our ears also, because as you saw with the latest version of the Oculus Rift, you actually also now begin to, you have built-in headset also in it, so you have now two senses, the visual and then, but what about the rest? If I take my legs and I start to walk, what happens? Unless that I have a number of complicated sensors, then nothing happens when I start walking around. When I have people experimenting with VR headsets, it's the first thing they start doing is that they want to explore the world that they're seeing now. So what do? They start walking, but nothing happens, right? They just turn around, then something happens, but when they start walking, nothing happens. So that's one of the big problems that we have. And because when people start walking, what is the first thing that happens? They walk into the wall, right? That's the next problem that we have also. So there's a number of things that has to be solved. One of the next frontiers that I see being solved right now is how we can interact with this content, with a very natural thing that has to do with what we use when we observe light, which is our eyes, of course.
Every day we use our eyes to understand the world around us. It's so natural and effortless that we don't really think about it. Unfortunately, our devices today lack the ability to sense our attention. Eye tracking will change this. It will enable you to interact with devices in ways you only dreamed was possible. Our vision is to transition eye tracking from from being an expensive lab equipment into everyday products. Soon, this technology will be integrated into a wide range of devices, such as tablets and smartphones. Today, you can get started with the eye tracker. This device can tell where someone is looking with a precision about the size of a fingertip. Devices will behave more intuitively. Games will become more immersive. It's the world's first affordable eye tracking device that contains some of the very latest technology. Bundled with the device comes our software development kit.
So once again, this is not a future vision. This is a product that's already out there on the street now, and you can go and order if you wanted to try it out for yourself. But the interesting thing about this is not really the external eye tracking, because that you can say it's an input method like so many other input methods that we have, for instance, with the mouses and stuff like that. But the interesting thing, and where I believe that things will begin to happen if you start mixing this technology together with the goggles. What do you get then? Then you get one of the biggest issues with perhaps you noticed what I said in the beginning, when Jones, they record their 360 high definition content, they record in something that corresponds to 1 to 2 gigabits per second. Now, if I want to be realistic about this, I could actually combine eye tracking with goggles, and this is what I get, right? I get an environment where I'm able to take, first of all, the initial 3D or VR environment that I have here, and when I start doing eye tracking, here I have nearly 100% utilization of the processor capability and transmission that I have. But if I start doing something different, which is basically I only show high resolution exactly where my eyes are looking into the goggles and into this image. What I can then do is I can take the advantage of the fact that I don't perceive colors, I don't perceive what is behind me, and I only see details exactly where my eyes are pointing at. So by this, just by this very simple technique here, I can already cut the processor capabilities or utilization of the PC down with 50%. Now, you'll remember that I said about one thing about 5G, which is the latency. If you want to efficiently be able to only send the part of a VR image that the person is actually looking at through a mobile network, you will need extremely low latency from the information from the sensor, where's the person looking at, how is he or her turning her head, to actually informing the server what information to send to the goggles. So this is why that low latency is extremely tied to the possibility of working with higher resolution and producing or showing high resolution imagery to people all over the world using a mobile network or fixed network for that matter, right? So for this reason, I think the combination that we will see is, of course, high resolution networks. We will see heavy recording of information, as I showed you with the rigs. One of the samples is what you've seen here already, but also with Jonte. And we will see different type of network-enabled technologies that, working together with the way we interact with the content, be able to cut down. Otherwise, we'll have the problem that you have today. If you want to buy an Oculus Rift, that is one price, but you have to pay 3 times as much just to buy the computer that can run it. So these are one of the ways that you can actually make this technology become much more affordable. And my take is that the companies that will develop these optimization technologies are the ones that will really democratize the way that we use virtual reality, or we're going to use virtual reality in the future. So with that, thank you very much for your attention.